Now, since we have defined the basic terms in vectors, it is time that we can go for addition of vectors. And the addition, as I have already told you some time back, that it follows the rules of vector algebra as against simple arithmetic that we use in scalar additions. So what are the rules, the laws of addition of vectors? We can have a look at them now. There are mainly three laws of vector addition, and they are called triangle law, polygon law, and parallelogram law. As you can guess from the name of the law, that first one involves constructing a triangle, second one a polygon of unknown number of sides, and the third one, which is the most convenient in most cases of adding up two vectors, that's parallelogram, construction of a parallelogram. So we shall learn about these laws in details one by one. First of all, we'll start with triangle law. So here on my screen, I have written down the expression for triangle law, what it says. Let us read it. If two vectors are represented in magnitude and direction by two sides of a triangle taken in the same order, the third side of the triangle taken in reverse order will represent the resultant of these two vectors in magnitude and direction. There are an important phrases here, in reverse order and also taken in same order. That will be important as we illustrate the law with the help of a figure. What the law is saying is this: suppose there are two vectors and they are represented as I am showing on the screen here. You can see there is a vector here and another vector we have. So I have drawn like that. Okay, let me name them. The first one is called the vector AB and second one is the vector BC. Now we can also call it AB is representing vector P and BC representing vector BC, that is representing vector Q. Then this is the way of two vectors representing in magnitude and direction. That means the length of AB represents the magnitude of the vector P and direction of P is along this line AB. Similarly, the length BC represents magnitude of vector Q and direction of Q is the same as BC. By two sides of a triangle taken in the same order. Now, the meaning of taken in same order is that it's A to B, B to C. It means the first ones, this is A is called the tail and B is the head. And the first vectors, the P vectors head and second vector Q's tail, they coincide. So that you go A to B, B to C. You are going actually anti-clockwise sense here. That is same order. You go like that. And then the third side of the triangle taken in reverse order. Let me clarify what it means. The resultant that is given by the third side in the reverse order. I have chosen a different ink consciously because I want to show the resultant here. Now this is represented by this red arrow, that is AC, and I shall call this vector AC as the vector R. So vectorially it means that the vector P, when added to the vector Q by vector algebra, that gives me a resultant vector. This is R. So you see the language also. P and Q are the combining vectors and R is called the resultant vector of the two combining vectors P and Q. Looking at the figure, the triangle ABC, the side AB, the arrow AB represents vector P in magnitude and direction. That is, the length AB is the magnitude of P, direction AB, direction of P. Similarly, the length BC represents magnitude of Q, direction BC, direction of Q. They are taken in the same order means it's A to B, B to C. The head of B coincides with the tail of BC. Then the third side, that is the AC, this arrow, AC in reverse order means you have been going till now anti-clockwise. To expect to be AB, BC, CA. That is the same order. But no, the third one, you take reverse, not CA, you go for AC, A to C. That's reversal of the order or sense. And that AC vector now, this side now of the triangle, will represent the resultant R in magnitude and direction. That means the length AC represents the magnitude of resultant R. The direction of AC the same as the direction of the R resultant vector. Now that is the statement of triangle law. Now once the meaning is clear, I could also write this. I will have the option of writing either using P and Q or using these letter heads. I have put ABC in the triangle. So this was the triangle ABC, and the law has said I could write AB vector. Here is the way of writing, another way of writing, where I have used the tail as the first point. This is called the initial point also of a vector, and B is the terminal point or head of the vector. So AB vector plus BC vector, that is equal to AC vector. Another way of writing, obviously here AB is P, BC is Q, and AC is R. That is what is triangle law. Now we can see a couple of corollaries with the help of this law. For example, this is the actual statement of the law, so I must give it a number and then highlight this for future references. Now the first thing that comes in my mind if I look at equation number 1 is this. This is obvious that if AB plus BC is equal to AC, that reversal of order is extremely important here. As you can see, I have reversed the order. It automatically means that equation number 1 could be written as AB plus BC, then bringing AC on the left hand side, that is minus AC, is equal to null vector. Be careful, I am just, since treating in vector algebra, I am not writing 0, I am writing 0 vector, that is null vector. Now I have said before that if one vector is this, suppose I call it a vector P or anything, let me give it some other name, I have already used PQ here, force vector say F. Vector that is minus F is represented by an arrow of equal length and anti-parallel. So it is minus F here, provided they do have the same lengths and parallel direction and opposite senses. So these are, each of them is negative of the other. So obviously by that logic I can say that when I write AC in my triangle on the left hand side, look here, AC was A to C. So obviously when I say it is minus AC, that must be the direction reversed, that is simply CA. Look at this triangle, what I am telling here. AC was A towards C. If I reverse it, if I take negative of that, that is obviously the same length, opposite direction, but the opposite direction of AC is CA. So minus AC means plus CA. So we could write it further and say we are getting AB plus BC, then minus AC becomes plus CA thanks to definition of negative vector. So these three together is coming out to be null vector. That's an equally important result that I'll be giving a little less importance. So let me give it another type of numbering in Roman, that is 1. This shows that if three vectors can be represented in magnitude and direction by the sides of a triangle, all taken in the same order, the resultant will be 0 vector. So just see once again what it says, the meaning of this particular result. AB, BC, CA, they are all in the same order, they are all anti-clockwise. You are actually going here, the whole thing anti-clockwise sense. I said once again, AB, BC, CA. Each one's head coincides with the next one's tail. Similarly, BC's head coincides with CA's tail, that is CA. I didn't say AC, I said CA. So AB, BC, CA, three sides of triangle, all taken in the same order, and their vector sum must be 0 vector or null vector. And that's a direct corollary of the actual triangle law that told us that if two sides taken in the same order represents two vectors in magnitude and direction, the third side in reverse order, that is AC in my figure, represents their resultant in magnitude and direction. That is triangle law's meaning. We shall see one more note or one more corollary from this, but I require some space for that. Now let me draw a coordinate system here. We are trying to explore the different connotations from the triangle law. This is a coordinate system. We may call it OXY coordinate system. O is the origin, and you have the X and Y axis, okay? And suppose a particle is traveling in this xy plane in a curved path like this. So maybe, in this case, maybe the particle is traveling this side actually. So initially, the particle is somewhere here. That point I called P1, that is initial location. And later, the particle has gone somewhere here. This is P2. So as I said, definition of position vector, you know that initially position vector was of the particle OP1, the arrow that is this. I'm drawing in a red line, okay? This was the initial position vector. Later, as the particle has traveled to P2, the new position vector comes out to be OP2. That is a new arrow drawn here, okay? So we know that we call this R1 vector, initial position vector, and finally position vector is R2. That is the two position vectors, as we have seen, as the particle changes position along this curved path. Now what about the displacement? Displacement, as we shall see shortly in a different lecture, is defined to be the shortest direct path followed by the particle. For example, if it has gone from P1 to P2 by this curved path, the distance traveled is actually the length of the path in actual. But a displacement finding you have to do is this. You have to just join the initial and final positions by a straight line and put an arrowhead there. So you see, in my figure, actually P1, P2, this vector, this is a straight line, the red arrow, that represents displacement. The displacement of the vector, right? Now you can see by triangle law that I am trying to show here, some corollary of triangle law. In the triangle OP1, P2, in triangle OP1, P2, we could write down that OP1, this vector, plus P1, P2, the two sides of a triangle taken in the same order, and their vector sum must be equal to the third side in reverse order, that is coming out to be here OP2. That's triangle law. Once again, OP1 plus P1, P2 is equal to OP2 in reverse order. But as you can check from here, that OP1 is nothing but R1. OP2 is nothing but R2. Then what is P1, P2? So the displacement P1, P2 is coming out to be OP2 minus OP1 is equal to OP2 being R2 and OP1 being R1. I could write like this, and P1, P2 might be called delta R. That is the displacement vector. This is the result, and P1, P2 is of course delta R, the displacement vector here. And that we have just now found to be displacement vector P1, P2 is given by the difference between the position vector of the final position minus position vector of the initial position. And that's an important formula that shows that displacement can be found by subtracting the position vectors of final minus initial position. An important result that will be coming many times handy and helpful when you deal about kinematics in a plane, motion in a plane or in space. So let us quickly recap the results we have got so far for triangle law. The first, the law itself has said, in any triangle, if two sides taken in the same order represents two vectors, their resultant is given by the third side in reverse order. That was AC, that's important. And by shifting AC on left hand side and rearrangement, we have got another important result. That is, if three sides of a triangle taken in the same order, AB, BC, CA, reversal of AC, that is CA, if they are taken, their vector sum would be zero vector. Obvious corollary from the first one, So this one is a corollary of the actual triangle law. Now, another important result we found is this. If a body moves in a plane, like in XY plane or in space maybe, if body travels from P1 to P2, as you have seen here, the displacement of the particle or the body is found by subtracting final position vector minus initial position vector. That's delta R, the displacement is equal to R2 minus R1. A useful result for kinematics.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.